care of superheating our lava in the back to 1100 degrees Celsius, 2000 Fahrenheit. And what he is wearing is a completely real volcanology suit. So this suit is what volcanologists use out in nature when taking samples of the lava coming fresh from the volcanoes, and it's made from material to reflect the heat of the lava, so with time his skin doesn't become too crispy. The gold plating here in the front on his helmet is made from the same material as we have on astronaut helmets when they go to space, to reflect the sun's radiation. But there's no such intense radiation in our lava in the back, just a lot of heat. So this whole uniform, whole thing, gloves and all, are made to reflect the heat of Max, so we can use it more than once. Now, Max, tell me, is... Do you have the flash on? Can I have a flash off in the balcony, please? Thank you. Alright, so those bubbles we're getting right now, this is the ice block we have in the channel, very quickly turning into steam and escaping through our lava, giving us these lava bubble explosions. Not deadly. Yeah. And this here is what we call Palle's hairs. Now Palle's hairs, they form in nature when lava falls off an edge and is picked up by the wind and pulled into these thin strands of lava. Now they're called Palle's hairs because of a Hawaiian goddess of volcanoes, but here in Iceland we have no Hawaiian goddess, we have witches. So we tend to call these witches' hairs, actually, yeah. And in Icelandic we call them nornahár. Just notice how rapidly cool down into these thin black hair strands. Now we saw what happened when the lava went over the ice. We had some very nice bubbles forming, but I have with me a second block of ice. Let's see. So, here I have a second block of ice. Do you guys want to see what happens if we put this on top of the lava? Yes, okay, good, me too. So, drop this on here. Immediately our ice starts melting and turning into steam, but you can see the lava lifting up. There is so much steam going on right now that the steam is being forced into our lava pool, trying to escape, giving us more lava bubbles. Very nice. But notice as well, everywhere the water is going and where we put the ice on top, the lava immediately turns black. It immediately fully solidifies. Because lava is a great insulator. That means that immediately when this lava entered the room, the surface became solid, keeping the middle from cooling down too quickly. So inside here we still have liquid flowing lava going into the pool. You can press on top of the channel here. This is all still very squishy. Same with the pool. And I might even, it's a big bubble, let's see. Might be able to break a little bit here. And inside everything is still very molten. Just from the super thin insulation the bubble formed, the lava on the inside is fully liquid. This is like less than a millimeter of insulation. Same here. Everything is still quite gooey. Now I want to check out this slide a bit more. Let's have a look. So, the slide is still a bit squishy, just about squishy enough for me to lift it up a bit. Because this is still a little bit soft in the middle, I can lift this up. And sometimes when we do this, we can get what we call a lava tunnel. Lava tunnels, they form in nature when we have a big field of lava and the lava drains out of the field, leaving behind a tunnel or a tube. And that is exactly what can happen here. We're lifting this channel up and the molten lava on the inside has a chance to drain down or flow down into the pool and leave behind a hollow tube or a lava tunnel. And now that I've held this up for a few seconds, you can take the stick back out. Just stays up. Very nice. Now for the pool. Let's see. Let's break this a little bit more. There we go. So the pool is still squishy. There's still molten lava underneath. So I'm gonna have a little peek underneath all three sides. So I will do this on all sides so everyone can see. Just gonna start here. And lift this up. You see this is still drooping down slowly. Still very bright orange and still just about as hot as when the lava first entered the room. When the lava entered the room, it was around 1,100 degrees Celsius. Under there, maybe it's down to 150. It's barely lost any temperature to be this liquid. Let's see. Of course, the more I lift this insulation crust up, the more I am breaking the insulation and everything starts cooling down a lot quicker. So I'm gonna try one more time for the middle section and a bit properly this time. So this time I'm gonna come outside the barrier here, try to get the stick underneath the middle of our pool here. See if we can lift this up a bit. Let's see what happens. Here you can see the texture is a bit different than in the beginning. When the lava entered the room, the texture is very liquid and honey-like and very easy to manipulate. Here you can see these black sheets forming. That means the lava is solid. The lava is more thick, it's more taffy-like. So we call this the taffy phase of lava. Very scientific as well. So the taffy phase is the last phase our lava goes through before fully solidifying. You can see this stretch a bit and then become black and solidify. I'm going to put this back down. Slowly crunches down. And we can even see the tip of the stick. It's going. Yeah. It's not melted though. Why is it not melted? Well, the stick that we are using here is made from stainless steel. Steel melts at 1,500 degrees Celsius. Lava melts at 900. So it takes a lot less heat to melt the lava than it takes to melt the stick, which is why the stick didn't melt. And it's the same with the slide and the furnace and the grates that I'm going to put on top of the slide in a moment. That is all made from different types of steel, much, much stronger than the lava, and it won't melt. Now we are starting to hear some popping sounds coming from the slide. These sounds are not dangerous, they're just the lava cooling down. I don't want to touch it. So, we're going to put one piece of paper here. Catches on fire immediately. One here, somewhere in the bubble. One here in the channel. Do you have a marshmallow? If you had one, I would let you cook. It would smell great. Yeah. I'm waiting. We've cooked a lot on the lava. We have done marshmallows and eggs and hot dogs and all of that. What we haven't done is a very, very fancy steak. So if you want to go to the store and buy the most expensive steak you have and let me cook it and eat it, that would be much appreciated. Yeah. Just if you feel like it, you know. Well, we've tried to cook a lot. That's one thing people tend to do in the active eruptions. People go and cook things on the lava. In nature, we've had 12 eruptions now in the past